Welcome back, grade 12s, to our online classroom. I am Mr. Pimbuyisa, your instructor once more. We are having lesson number 2 on mid-latitude cyclones. If you hadn't watched the first lesson, please pause the video and go back to the previous lesson and just take your time to watch it. Take some notes before you can watch the second lesson. Now, the second lesson is a continuation of what we did last time. Now, remember, in the previous lesson we focused on the first half of our session outline. So in today's session we are looking at the last half of the outline. So we are going to be talking about the associated weather patterns with a mid-latitude cyclones. So we'll be looking at what conditions are associated with a cold front, a warm front, and an occluded front. We are also going to be looking at some technical geographical skills you should know associated with these different fronts for examination purposes. You also need to know the impact that this system has on humans, the environment, the economy. And remember, I had said that the impact may both be positive or negative. And since the impact may be negative, you need to know some of the strategies we can employ to mitigate the impact, or to prevent or reduce the impact. Without wasting any time, let us get to it. Now, as I said, we are looking at associated weather patterns. Now, the picture here is showing us a satellite image of a mid-latitude cyclone. Remember, we had looked at that. Now, if you look at the satellite image, you see that the system is associated with dense clouds, and dense clouds in some parts and scattered clouds in some parts. So we are going to be looking at what fronts are represented by the clouds and what conditions do they respectively bring. So let us look at that. Yes, so now we need to first, before we think about conditions associated with the system, we need to go back a bit to what we discussed in the previous session. Now, we talked about where you would find this system forming, and we said the system will form between 30 and 60 degrees, both north and south. Now, what you must know is that in the different hemispheres, when we draw a diagram showing our mid-latitude cyclone, it will be represented slightly differently, simply because of the location of our polar region and our subtropical westerly wind belt. So you need to take note of that. Now, to make things easy, let me just draw a diagram to represent that. Now, the diagram shown here is representing a mid-latitude cyclone in the northern hemisphere, and this one is representing a mid-latitude cyclone in the southern hemisphere. Now, let me draw a diagram to show you why am I saying so. Now, I'm gonna draw half the Earth and another half Earth here. Right, now this is representing the equator, which is the 0-degree line of latitude that separates the Earth's southern hemisphere from the northern hemisphere. Okay, so you have your 0 degrees there, and my 0 degrees is a bit funny, but it's fine. I'm improving with the writing, guys. So you have your 30-degree line of latitude here, and you have your 60 here. So that's what you have. Now, that's where the system forms, right? Now, again, in the southern hemisphere, you have similar lines, right? So you have your 30-degree line of latitude over there, and you have the 60 degrees line of latitude over there. Okay, now going back to what we discussed in the previous session, we said that this system forms between 30 and 60 degrees, where both north and south. Now, what does that mean? Now, you'll remember that we have air of different moisture and heat in the distinct hemisphere. So we know that in the 30 degree line, we have your westerly wind belt. We find that we have our westerly wind belt. Now we know that now in the 60 to 90 degree line, we have our easterly wind belt. Now this is the polar easterly wind belt, which means the air over there is cold. So we find our cold polar easterlies, and where there is the yellow color, we find our warmer, slightly warmer westerly winds. Now we said for the system to form, the two air masses must meet. Where do they meet? They meet at the 60 degree line of latitude, being the polar front. Remember, a front separates air of different temperature and moisture. So that's what you'll have over there. Now, how then does that affect how the diagram will look in either hemisphere? Now we know that in the northern hemisphere, the poles are up there, right? And it means our cold air will be slightly upper there. Now it means in our diagram, our cold sector that will form will be upper there. So your cold sector is upper there. Remember, the cold sector is behind the cold front, because we name fronts according to the air that is behind it, or the air that is found behind the front. So that's what you will have. Hence, your diagram will look slightly upside down in the northern hemisphere. So if they ask you in the exam and give you such a diagram, you must know that it's in the northern hemisphere, simply because your cold sector is facing up. And another piece of evidence we can use is the circulation of air. So if you look at the arrows over here, remember this is a low pressure system, and we know that low pressure systems will circulate in an anti-clockwise direction, where in the northern hemisphere. So that those are two pieces of evidence that you can use: the location of the cold sector and warm sector. Remember, warm sector will be below, because your westerly wind belt is below the polar belt, or the cold polar easterly wind belt. Yeah, so those are pieces of evidence you can give for examination purposes, and it's just some stuff that you have to understand for yourself as well. And if you look at the southern hemisphere, the opposite is true. Now the first thing you can think about is the location of the poles. The poles are below, right? They're below the westerly wind belt, so it means our cold sector will be below there, and our warm sector will be upper there, because our westerly wind belt is located upper there. And another piece of evidence you can use is the circulation. Since in the northern hemisphere, low pressure system circulating in an anti-clockwise direction, it means now opposites. Remember, in geography we deal with opposites. It means in the southern hemisphere you'll have a clockwise circulation of air around your low pressure system. Remember, your golden rules, they still apply here. So I hope we understand that in different hemispheres we will look at, or rather we will represent the system differently, simply because of the location of the different belts in which the system would form. Now let us think about the conditions then associated with the different fronts. Now starting with the cold front, the conditions associated with the cold front. Now remember, in the previous session we had said that in the mature stage, what will happen is that your fronts will be fully developed, and since the fronts are fully developed, certain things start happening. Now, when the fronts are fully developed, number one, it simply tells us that we have air entering the system. We have air entering this mid-latitude cyclonic system, right? So, and what does that mean? It means now we have cold air sinking rapidly. Now, as the cold air sinks rapidly in the cold front, it will force the warm air to rise rapidly, and as it rises, remember, the higher you go, the colder it becomes. So as this warm, moist westerly air rises, it is going to cool down or condense, and clouds are going to form, and the clouds that form in front of the cold front are known as cumulonimbus clouds, and as a result you'll have precipitation forming. Now, in the exam, you would be asked then, what will happen, how will the atmospheric conditions change when a cold front approaches? Now remember, in front of the cold front we'll have the warm sector, right? And over there we'll have our cumulonimbus clouds having formed and precipitation happening. So now we look at different aspects when we look at how the atmospheric conditions will change. So the different aspects that we look at are basically the same aspects you will look at in a weather station, right? So we look at temperature, we look at wind direction, we also look at cloud cover, we look at the cloud type, we look at pressure, and we also look at what will happen to rainfall or precipitation. So those are the different things we think about. Now, when a cold front approaches, what happens to the temperature? The temperature will decrease. Why does the temperature decrease? Simply because, remember, we said the warm air will rise rapidly, and when it rises rapidly, it will cool down and form clouds, cumulonimbus clouds, and these clouds are associated with severe thunderstorms and rainfall. And of course, when it rains, temperatures decrease, right? And what will happen then to the cloud cover? Cloud cover is overcast. Why? Because of this rapid rising warm air. What happens to the cloud type? The cloud type we have is cumulonimbus clouds, as we had already discussed, and the pressure will increase. Why pressure increases? Simply because of the relationship between temperature and pressure. Remember, we said they are always going to be opposites to each other. So since the temperature is decreasing, our pressure will increase. And since we have overcast skies and cumulonimbus clouds, we are thus going to have what? Heavy rainfall or thunderstorms. And in mountains or high-lying areas, we usually have snow as a form of precipitation. So that's what will happen when a cold front approaches. Now you may be asked what happens to the wind direction. So the wind direction, will change, and why does it change, or how does it change rather? That's what we really care about. Now before that, we will have normal westerly winds in the westerly wind belt, but when a mid-latitude cyclone comes, we have now a change from westerly winds to southwesterly winds. So that phenomenon is known as bucking. So bucking happens, so our wind direction changes from westerly to southwesterly, and that is true for the southern hemisphere. Now in the northern hemisphere, we have veering taking place. So our winds change from westerly direction to northwesterly direction. So veering takes place over there. So let's just take note of that. And why is it northwesterly direction, guys? It's simply because of the effect of the pressure gradient force. Remember, it still has an effect. Since the air, let me just describe it with a diagram. So if this was our southern hemisphere, and in the southern hemisphere, this was the 30-degree line, 60-degree line and 90-degree line. So remember we said the system forms from 30 to 60. Now we know that the 30-degree line is a high pressure belt, the subtropical high pressure belt. And at 60 we have the subpolar low pressure belt. And here we have the polar high pressure belt. Now you may ask yourself, why is it moving? Why is it backing? Why is it moving from west to southwest? Now when the system comes, remember pressure gradient force says air must move from high pressure to low pressure. So when this system comes, it is also propelled or pushed by your pressure gradient force. So as much as it is going to the east from the west, remember in the westerly wind belt, as much as it's going to move from west to east, it is also going to be moving towards the low pressure. That's why our winds change from west to southwest. So it's going southwards because it is pushed towards that side by the pressure gradient force. In case they ask you that, so you need to understand that, and that is why we covered that in the golden rules and part 3 of our revision on the application of the golden rules, so you know how the vertical pressure gradient force and horizontal pressure gradient force will apply in this case. I hope we understand that. Now, going back to now the reasoning behind it, you need to know the reasoning as well. Now, why does temperature decrease? Why? Because behind what's this cold air behind? There's cold air behind the cold front. And why does the wind direction change? Simply because of the clockwise rotation of air around the low pressure, and also the effect of the pressure gradient force. Remember that. Remember air current or the circulation of air. Remember rule number 12. The circulation of air influences air current and the circulation of the system as a result. So remember that. So the vertical pressure gradient force has some role to play in that. And then what happens with cloud cover? Cloud cover, we have overcast. Why? Because we have warm air rising over the approaching cold air. So this warm air will cool down or condense, and we will have the formation of cumulonimbus clouds. Now, why do they form? Simply because the cold air forces the warm air to rise sharply, therefore condensation occurs at great heights. So that's how cumulonimbus clouds will form. And why does pressure increase? Because pressure at its lowest, or rather pressure is at its lowest just before the cold front comes. So when the cold front arrives, our pressure will spiral up or increase. And remember the relationship between temperature and pressure. So when temperatures decrease rapidly, our pressure will increase rapidly. And remember, we derive the pressure from weight. So our air will be more heavy, more dense as a result. So it will be really cold. And why do we have heavy rainfall, thunderstorm, and snowing? It's simply because of strong convection. So the rapid rising of the air will cause cumulonimbus clouds to form, and these lead to thunderstorms. So I hope we understand that. Those are the conditions associated with your cold front, and this is the reasoning behind it. So the diagram on the screen is showing us exactly that. Behind the cold front, we have cold air. And remember, we draw the cold front as a curved line. So this is a cross section of the cold front. We draw it as a curved line. Why? It indicates the steep pressure gradient force over there, which means the system will be associated with a very, very, very strong winds as a result. Are we fine with that? So that's what you will have. And cumulonimbus clouds will form in front of the cold front simply because of rapid rising air as a result of the sharp sinking of the cold air propelling this warm air to rise rapidly, leading to the formation of cumulonimbus clouds due to rapid condensation. I hope we are fine with that. We may have some other clouds. Remember, this is the warm sector. We may have altostratus clouds, cirrus clouds, and so on and so forth. And cumulus clouds in front, behind the cold front. Now let's think about what will happen in the warm front. Talking about the warm front conditions or conditions associated with the warm front, the first thing that we have to really sort of remember is that we are looking at a front that is formed by warm air, and in the previous part we are looking at a front that is formed by cold air, and looking at both of these, we can all agree to say that they will both be associated with slightly totally different conditions. And that's something that we can agree with, right? Now, since we agree with that, we then have to then think about how will the atmospheric conditions sort of change when you look at the two systems, or rather the two fronts rather. Now, thinking about a warm front, how will temperature change? We say temperature will increase, right, as you can see here. Why? Because we have warm air, and we know that with warm air our temperature is slightly higher. Now, the temperature will increase simply because there is warm air behind the warm front. Are we fine with that? So that's what you'll have. And then now with wind, again, what will happen is backing will happen. Now your southwesterly winds will become your westerly winds. Remember, it's still on the system being affected by how the air will choose to circulate. So it's still more or less the same effect. So in the northern hemisphere, you'll have veering as a result. So remember, clockwise rotation of air around the low pressure leads to that. The cloud cover will decrease slightly. Why does it decrease slightly? Remember, in this front, we don't have air rising rapidly, so we have a gentle pressure gradient over there. That's why our line there in the cross section is represented like that, to show a gentle slope over there. So we have a gentle pressure gradient, which means we don't have really strong winds over there as a result. Now, thinking about the cloud type, we are going to have nimbostratus clouds, and these nimbostratus clouds form due to our warm air cooling down slowly as it rises. So because of the condensation, we are going to have nimbostratus clouds forming as a result of that. And then what happens to the pressure is that the pressure will decrease. Remember, temperature increases, so remember these two are always inversely proportional to each other, or they are opposite to each other. So you are going to have a decrease in pressure. And why does pressure decrease? Simply because our pressure is at its lowest because our temperature are slightly more higher in the warm sector because of the presence of warm air. And we know that when our cold front approaches, then we are going to have pressure increasing. So it is at its lowest in the warm front simply because this is basically the segment of the front that is found before the cold front brings these extremely cold or low temperatures. And then what happens to precipitation? You have little to no rainfall So you have little to no rainfall because we have nimbostratus clouds. So you may have showers as a form of precipitation. And what causes that? It's the rising of air, right? Within the warm front. So those are the associated weather patterns with a warm front. Now, in essence, what we have done is to basically look at the conditions of the system in the mature stage. Now, remember, we represented the cold front. How did we represent? We said it has a curved line to represent the steep pressure gradient force, and in the cold front, right? And in the warm front, it's slightly gentler because of our gentle pressure gradient force. Now, in front of the cold front, you'll have cumulonimbus clouds forming. So you always have to draw these clouds in your cross section. And behind that, you need to label that we have cold, dense air moving under the warm air. Now, since this cold, dense air moves under the warm air, it causes the warm air to rise rapidly above this cold air, and it will condense and form cumulonimbus clouds over there in front of the cold front. So in the warm front, the opposite will happen. We still do have the warm air rising, but it is not rising as rapidly, and as a result, you have nimbostratus clouds forming in the warm front as a result. And you may have little to no rainfall or just showers over there as a result. In your cross section, you also have to label the general movement of the system. Remember, it moves from west to east. So it will go to the easterly direction from the westerly direction. So that's how the system will move. You need to represent that in your cross section. Then let's just look at a summary then of everything we've looked at. We said that with a cold front, air pressure increases. And why does it increase? Simply because there's a decrease in temperature. Remember, the two are always opposite to each other, which means with a warm front, since temperature increases slightly, your pressure will decrease as a result. Now, what happens to the cold sector? Remember, the cold sector has cold air, so we are going to have an increase in pressure, and we are going to have low temperature that are lesser than 10 degrees Celsius. While with the warm sector, remember, it has warm air, so our air is around 12 degrees Celsius and above, and our pressure stays a bit balanced, right? It stays a bit balanced. So that's what you will be having. And what happens to the movement of the cyclone? There is a what's this? As the cyclone approaches, the pressure steadily decreases simply because the cyclone is a low pressure system. And what happens to the temperature of the cyclone? It basically cools to around 8 degrees Celsius. Let's talk about wind direction. Wind direction in the cold front, backing happens, so we have winds moving from west, or changes from west to south west in the southern hemisphere, and in the northern hemisphere veering happens, so we have west changing to northwest in the northern hemisphere. In the cold sector, we have southerly winds. In the warm sector, we have westerly winds. In the warm front, the same will happen, backing and veering. The wind speed in the cold sector will decrease. And why does it decrease? The cold sector, we have a more descending air that is dense. In the cold front, we have very strong gale force winds. Why are the winds strong? Because we have a steep pressure gradient force in your cold sector. So remember that steep pressure gradient force, if we were to represent that within a synoptic weather map, we'll have isobars being closer to each other, showing that we have a steep pressure gradient force, and as a result, you'll have the strongest winds over there. In the warm sector, these winds decrease decrease, of course, because we have light air rising, not an issue. Now in the warm front we have very strong winds, of course, as well. Now thinking about the relative humidity, the cold sector is low in humidity, because remember the cold sector is made up of cold air, and cold air is mostly dry. Remember the golden rules. Cold air is mostly dry. In the cold front, we have high humidity due to the rainfall. And remember, rainfall is caused by this warm air being propelled to rise rapidly as a result of the cold air sinking. So we are going to have high humidity there. So in the warm sector, we'll have high humidity, of course, because the air is warm and moist. And in the warm front, we have high precipitation due to nimbostratus clouds causing showers, right? So the humidity will also be relatively high over there. And then cloud cover in the cold sector is cumulus. In the warm sector, we have low stratus clouds. Cold front, towering cumulonimbus clouds. Remember, they form because of rapid condensation, while in the warm front we have nimbostratus clouds forming as a result of air rising slowly in the warm front because of the gentle pressure gradient force. And precipitation, the cold sector, we have heavy showers due to the cold front. In the cold front, we have short period of heavy rain and hail and snow, possible snow. In the warm sector may cause drizzle. Remember, drizzle, it's that rain, smaller drops of rain. So that's drizzle. In the warm front, you'll have light showers, or you can just have fog, depending on the intensity of the system. The visibility. When you're in the cold front, it is visible because we have dense air. Remember that we have dense air that is dry. What decreases the visibility is the moisture. Remember that. So we have less visibility with the cold front, simply because we have rainfall and fogging being a possibility. The warm sector also less visible due to fog as a result of the warm air there. And again, in the warm front, you'll also have the same. Now, looking at what happens when the general system, the cyclone, comes, we said pressure will decrease steadily. Temperatures will be cool or just around 8 degrees Celsius. The wind direction will be northwest in the southern hemisphere and southwest in the northern hemisphere. The wind speed will steadily increase when the system comes. Wind speed increases, relative humidity will also rise. The cloud cover, you can either have altostratus, cirrostratus, and cirrus clouds, right? Remember, you did the types of clouds in grade 10, so just revise the conditions associated with each type of cloud for additional knowledge. Precipitation, we have none. So when the cyclone generally approaches, there's no precipitation, but when a cold front comes, then we are going to have precipitation, or when a warm front comes. So here, remember, we are looking at what will happen when the cyclone approaches in general. As it is approaching, what will happen? And visibility, less visible, because when the cold front then approaches, we are going to have some bit of rainfall forming as a result. Then let's talk about conditions associated with the occlusion stage. Now remember, the occlusion stage, we have two types. We have cold front occlusion, where the cold front catches up with the warm front. Now if you look at your symbols there, with cold front occlusion, your triangle symbol, remember, represents the cold front. You see it's the first one there, followed by the warm front, then the cold, the warm, the cold, and so on and so forth. So since it's cold front occlusion, simply because it simply shows us that the cold front has caught up with the warm front, and as a result we'll have slightly colder conditions, as we have the cold air occupying the surface as a result over there. So remember how you identify your cold front and warm front occlusion, look at the symbol. So the first symbol there is a triangle. Now with warm front occlusion, the first symbol there is the warm front symbol, so that is warm front occlusion. So you need to be able to show that in the exam. And remember, warm front occlusions as a result of the warm front catching up with the cold front. Now remember, when the cold front catches up with the warm front, the cold front or the cold air in the cold front will undercut the warm front. The cold air will undercut the warm front, which means it will go submerge under the warm front, and as a result you'll have colder conditions in the ground. And with warm front occlusion, we'll have the warm front overriding the cold front. And as a result, you may have some showers, a bit of rainfall as a result. So those are the conditions associated with that. And remember, the same will apply. Since we have, with cold front occlusion, we have a lot of cold air in the surface. Think about what happens when temperatures are low, the pressure will be high, and think about how wind will be. Remember, we say cold air is associated with stable weather. So think about those conditions. While with warm front occlusion, will have slightly showers and all, or foggy conditions. And again, over there, think about conditions associated with a warm front or warm air. So unstable weather may result as a result of this phenomenon. So let's remember that for examination purposes. So now I want us to then think about the last part of our lesson, so which is looking at the impact this system will have on humans, the economy, and the environment. Now remember, for all the topics, you'll be expected to be able to identify the impact. Are we fine with that? And remember, I said the impact may be positive or it may be negative. So you need to be able to identify this and give reasons. So this is usually asked in a paragraph question in your examination. So you need to be conscious about this, and this is the last part basically of the topic, mid-latitude cyclones. So I hope we understand the work we've covered so far. So without wasting any time, let us look at the impact on humans. The system has a dualistic impact on humans. Now, what does that mean? It means as much as the impact may be positive, it may also be negative. And vice versa, of course. Now, looking at our short notes, I've covered some of the positive impacts, some of the negative impacts of the system. Now, remember we said in South Africa, the system will occur or rather will affect us only in winter. Now, what's the benefit of that? We did the associated weather patterns, and we said that the cold front will bring rainfall. So that's a positive to say in winter. It means now we are going to have winter rainfall in the west coast of the country. And what good does that bring? It means now we can have water to irrigate our crops. So agriculture can take place as a result. So that's a positive impact. Now, another thing is that when we have rainfall, it means our dams and rivers can be replenished, right? And it means now we are going to have more water for domestic use. And another positive is that the snow in mountains will replenish basically the water or the humidity of the mountain. Remember, we have Table Mountain over there. As this water, rather the snow will melt into the plants, and it means Table Mountain will stay beautiful in winter. So this is going to attract what? It will attract tourists. So that's another positive effect of this. You can think about more. I've just mentioned some of the few over there. Now, a negative impact then is that, number one, snowfalls may be dangerous for people at times. And when we have very low temperatures associated with the cold front, this may lead to disruption of human activities. So people may stay indoors, they may not go to visit places simply because it will be too cold, and when it rains, it's also a problem. So it may affect tourism negatively, and certain human activities as well negatively. And again, we know that winds will occur before the system comes, so they may develop where in the warm sector, which may cause felt fires, leading to damage of infrastructure and all of that. Now we know that the system is associated with gale force winds. Gale force winds are strong, fierce winds behind the cold front, which may result in ocean storms, which may damage ships over there, thus affecting people and may lead to loss of life as well. Now we know that heavy rainfall decreases visibility, so it leads to foggy conditions, which may lead to traffic and road accidents. And we also know that when we have heavy rainfall, it may lead to flooding, and that may lead to loss of lives and damage to residential areas. And flooding again may damage water systems, decreasing the water quality and water availability as a result. So these are some of the negative impacts. Those are some of the positive impacts of this system on humans. So let us look at more. Now, looking at the negative impact on the economy. Again, just to continue, we think about flooding. So flooding and snowfalls may damage crops and may lead to loss of life in terms of livestock. So that's a negative. And we know that highly low temperatures may damage some crops and livestock. We also know that these berg winds may damage vegetation and also affect or lead to loss of biodiversity, right? And we know that the gale force winds may damage crops as well, because these winds are really strong. So some of the crops may be uprooted as a result of that. Now, a positive on the economy is that winter rainfall is good for agricultural production, which leads to food security. And remember, when members of society are well fed, the GDP of the country will be high. And remember, when we can also produce crops in winter, that will increase our export market, which will increase our gross domestic product, or our GDP. Per capita. And we also think about how winter crop farming may lead to job creation. So members of society may get jobs, winter jobs, and basically people that work in the farming part may get work throughout the year, as the farming will happen both in summer and winter as a result. So these are some of the positive impacts on the economy and the negative impacts. And let's look at the negative impacts and positive impacts on the environment. The positive is that the rainfall will lead to more water in rivers, which will benefit aquatic life, and the production of winter crops benefits the GDP, and also benefits, we can say, the natural environment as well, as some animals may have food as a result of the farming being produced, right? So that is an impact on the environment. Of course, it may be connected to the economy and humans in some aspects, so let's also remember that. And a negative is that flooding may lead to death of animals, which may negatively impact on biodiversity. And remember, floods may also lead to soil erosion. It's a problem environment. It will be expensive then for farmers to protect crops and livestock, and floods can also damage crops and impact negatively on the economy as a result. So these are some of the impacts on the environment. They are connected to human activities and the economy. So let's just always think about how we can apply that. Now, since we've discussed the positive and negative impacts, now how can we mitigate the negative impacts? Now, part of the precautionary management strategies we can employ to reduce the impact of these cyclones. Number one is that we need to improve our meteorological works. Now, what does that mean? It means we need to assess the day-to-day changes in atmospheric conditions so that we can detect these mid-latitude cyclones when they develop very early, so we are able to warn people or communicate people so they prepare for them. We also need to evacuate some people that may live in coastal regions to decrease the effect of flooding if it floods when the system may come, and also encourage people that live in low-lying areas to build away from these regions. So that may decrease the impact of flooding, right? So we also need to evacuate livestock and put it where? In barns to protect it against floods and cold conditions. We also need to plant what? Cold resistant plants so that they can withstand the cold conditions. Also, the media needs to encourage people to hibernate so they protect themselves against conditions associated with the cold front to avoid loss of life. Remember that putting sandbanks along rivers will reduce the impact of flooding. That's another thing we can put in place, and we also need to build artificial flood plains along rivers and also practice rice farming. So remember, rice farming sort of decreases the impact of the flood. It will reduce the impact of the flood by reducing the speed of the fast flowing water as a result of floods in those regions, thus protecting people. So these are some of the things that we can put in place as precautionary measures. Remember guys, precautionary measures are just to reduce the impact. They don't completely or entirely take away the effect of the system. So let's remember that you may be asked to provide these again as paragraph questions in your paragraph questions in your examination. So familiarize yourselves with this information so that you are able to do so. So I hope we understand this section of work and we are fine. Now let us summarize quickly. Now in summary, remember the first part of the lesson was looking at the associated weather patterns with the different parts that make up a mid-latitude cyclone. So we looked at conditions associated with the cold front, conditions associated with the warm front, conditions associated with the warm sector and the cold sector. And we also looked at the impact of the mid-latitude cyclones on human activities, on the economy and the environment. And we also then looked at the possible precautionary measures we can put in place to address the impact of mid-latitude cyclones. So that's what we talked about in this session. So I hope we are fine. If there are sections of this work that you need more clarity on or that you didn't fully understand, feel free to re-watch this video or download it to your device and re-watch it throughout the year, because the work we are doing now will form part of your term test, your June exam if your school has previous one, your preliminary exam and your final examination. So please keep on going back to this video or this lesson so that you are well prepared for your examinations. Now coming up is mid-latitude cyclones, lesson number 3. And lesson number 3 is an application lesson. So we'll be looking at how you can approach some of the examination questions on this section. So we'll be looking at how do you practically apply the work that we've covered in these 2 past lessons on mid-latitude cyclones. So please do tune in on this platform, same time, same place. We'll be happy to have you. I am Mr. P. Mbuisa. Once again, I am happy to have you in my online classroom series, and see you next time in lesson number 3.
Audio Jungle.